No, screen is visible.
Yes, ma'am.
Yes. Yes, we have completed up to display size. Display devices we have started. Okay, resolution we have completed, pixel, refresh rate, then display size. Now next is the display aspect ratio. We denote it with DAR. What is the aspect ratio? Aspect ratio is the you can say the height and width of the screen. Width and height of height of the screen is the display aspect ratio. If you see na previous time there was a square shaped TV, square shaped screens in monitors, you can say like that. So they are square shaped. So their aspect ratio you can say that 4:3. 4:3 means to say कि its width is 4 or its length is 3, its height is 3. So now today's you see the LCDs, LEDs in your homes. So that ratio is like you can say that its height is 9 or its width is 16. 16:9. That is the aspect ratio of the display device. Got it? Width and height of the display. 16:9. Now height is less, width is more. Now today's screens are coming like that. LCDs or LEDs display units. You will see their height is width is more, but height is less. So ratio you can denote it with 16:9, 21:9. The width is height is same, but width is increasing. Width is increasing, height is almost same. Got it? Please.
Yes, ma'am.
Yes, this is called display aspect ratio. This denotes with display aspect ratio. Now, this is an important word we are going to study or learn. Raster graphics. Two words are there: raster graphics and vector graphics. What are these? What are these terms? Raster images are composed of tiny pixels. We have learned about pixels now, horizontal and vertical dots in the screen. There are so many dots in the screen, square shape, horizontal and vertically. So these called pixels. So raster images are made up of tiny pixels, each representing a specific color. These pixels combine to form. When these pixels combine, make a entire image. When you zoom in on a raster image, you will notice individual pixel. Like we see in the example, this is a raster. When we zoom, your pixel will become your screen will become blur. But in raster vector zoom, your image will be sharp. Okay. So when you zoom in on a raster image, you will notice individual pixel. You will see the squares, little bit squares in your picture side. In side of the picture, you will see the your little dots or little squares. Okay, that is called pixels. Common examples include JPEG and GIF files. You will when you zoom it, you will see these things, these dots or these pixels in your image. Raster graphics are detailed but have limitations. These have some limitations. File size. Larger raster image requires substantial disk space. So when obviously if the image is more, if the image is big, large, it will take more space. So for instance, a 640 into 480 image. We know in the resolution we done about the width and the height. This is the width in the width, horizontal pixels, and W denotes for horizontal pixels. 1920. Here is a 1920 pixel in horizontal. 1080 is pixel in vertically. So in this way, 640 is in horizontal, 480 is in a vertically. These are the pixel. Okay, these are the pixels. So when we multiply these two numbers, we will get the pixels in this number of the pixel. Okay, so if the our image is large, the pixel will be more, it will cover the more pixel, it will store, it will take more space. Okay, so this is the limitation. So there are some when you save some raster graphics, there are some specific file formats. As we know now, when we store some, when we save some PPT, suppose for example we save PowerPoint, we need file format dot PPT, PPTX, for Word dot docx, doc, for uh, sorry, like Excel. There are every file every file extension, every there are so many file extensions to save the file. When we want to save the image, there are so many extensions, there are so many extension file formats we used. These are so we have to remember these file extensions related to raster graphic. So related to raster graphics, TIFF, tagged image file format. This is the file format for raster graphic. Also PSD, Adobe Photoshop document. When we save the image, when we store the image in Photoshop, we use the extension file format PSD. Okay, Adobe Photoshop document. PDF, for PDF, we save, we store in image or a text in portable document format, in JPG, joint, photographic expert group. This is also JPG. When you remove the expert, it will become JPG. When you add expert, it will become JPEG. Okay, JPEG. Okay, they both are same. PNG is portable network graphic. GIF is a graphics interchange format. BMP is a bitmap image file. These are the file formats for raster graphics. Okay. Now scaling. When you enlarge a raster image, it's a blur. It becomes a blur or pixelation. That word we used for blur, pixelation or blurriness. Okay. File extensions, as we know, .bmp, .tif, .gif, .jpg. So next is a vector graphics. Vector graphics use mathematical parts. Yes, as we know now, who knows about some, you know about some maths, like in geometry, we use some, like we want to make some, draw some triangle. So we take some angles, we use some angles, we use some path to draw that triangle, like isosceles triangle, right angle triangle. We use some path. So same form, we use some formulas in mathematics to draw that image or draw that figure. So in the same way, in vector graphic, we use that formula, or you can say that we use some path to draw some image. Okay, so these paths are defined by mathematical formulas. Unlike pixels, in a raster image, raster graphics, we use pixels. Okay, and in vector graphics, we use mathematical paths. Unlike pixels in raster image, vector graphic remain crisp even when enlarged. Yes, when we zoom in a vector image, it becomes sharp. Its image is very crisp. Its crispness doesn't remove. Okay, it becomes as it is. Key points about vector graphics are print quality. Obviously, if the print quality will be better than the raster graphic. So small file size, but the limitation is it's in raster graphic, you can make some larger images, but in vector you can make only small images. You can't make large images. Okay, so instead of storing individual pixel, vector files use command to describe points connected by lines. So it's a smaller file size. It means that it has a smaller file size. You can't use larger file size for this vector graphics. In vector graphics, there are file extensions for vector graphics: .svg, .eps, .pdf, .ai, .dxf. AI is for Adobe Illustrator document. EPS for encapsulated postscript, SVG, scalable, vector graphics, PDF, portable, document format, only when saved from PDF is also in the raster graphic na. PDF is also used in the vector graphic also. But when we this format will be used when you save your program in vector program. Okay, then this PDF will be used. This file format will be used. DXF for drawing exchange. Okay, so there are some differences between raster and vector graphics. Raster graphics are composed of pixels, yes, while vector graphics are composed of paths, mathematical paths. Pixels are tiny squares of color that form an image. As I told you that horizontal and vertically they make some boxes, little dots. These are called pixels. So while paths are mathematical equations that define the shape, border, and fill color of an image. According to the mathematical equation, you define some shapes, some borders of that image. You will fill the color of that image according to the mathematical equation. Some path will be there to draw the image. Raster graphics have a fixed resolution. Yes, which means they lose quality when you zoomed. It will lose quality because it has fixed resolution. Means to say it has some fixed. If you if you make some image, it will take some horizontally and vertically pixels. You save in your image in a particular, suppose you are saving your image in 100 into 100. Suppose you are, I'm just taking example, 100 into 100 pixels you are saving your image. When you expand it, when you zoom it your image, it will obviously blur because you are expanding. Your pixels can't take if you will expand your square, that pixel, it will become blur, but in vector graphics are resolution independent. They are not dependent on your resolutions, they are not dependent on your pixels, which means they can be scaled up or down without affecting their quality. You can increase the image size of the image, you can decrease the size of the image, but they don't affect on your quality of the image. Raster graphics can display a wider range of colors and shades. Yes, basically we use the raster graphics because they are in raster graphics. We can use more colors, more range of colors and shades, which makes them suitable for realistic images such as photographs. When the in photographics, raster graphics are used because there are we need so many colors. We use so many colors to make it a real image. So we use raster graphic. Vector graphics are more limited in color and shading. They are better for simple or abstract images such as logos, because logo is a we make some logos in vector graphic, because when we zoom it, pixels doesn't you will see when you zoom out your logo, your logo will not be affected, it will not be blur, it will be crisp, it will be sharp. So these are because these are made up of the vector graphics, sorry. Icons, your icons, you will see some icons are made up of vector graphics, illustrations. Raster graphics are easier to edit and manipulate. Yes, we can it is easy to edit and manipulate, but they require more storage space. As we discuss about this, they take more space and processing power. Obviously, if they are taking more space, the processing time will be also increased. Vector graphics are harder to edit because when we make some logo, we can't edit this logo easily. Okay, they are more efficient and compact. So this is about vector graphic and raster graphics. Okay, sometimes questions can come in related to raster graphics and vector graphics, because some previous year questions, there are some questions related to this topic, raster graphic and vector graphic. So they can ask about file format, they can ask about difference in vector or raster. And this is basic difference. This is not much more typical, because in raster we use the pixels, in vector we use the mathematical path. Okay, so some you have to learn about the uh, file formats name. Okay, they can give you the file format. You have to just give the difference between what is it related to vector or is it related to raster. This is, or you can they can ask about the full forms, abbreviations related to this, because in ICT there are so many abbreviations. So we will discuss according to the topic. Okay, topic by type topic we are doing, they are related to their abbreviations. Got it? Please.
Yes, ma'am.
Yes. Now next we will do, we have completed monochrome, grayscale. So this is I have added one image related to monochrome. This is the this is, there is only two colors. Backside you will see the background color is black, and front text is in the green color. Okay, it can be white color. There is no mention is it can be green or it can be white color. So this is related to monochrome monitor. Grayscale monitor, we know about the black and white TVs, like black and white TVs. We if we you will see that na, sometimes we make our image in the in black and white form. So that is all related to grayscale. Okay, color monitor, as we know, we are using in today's life. So cathode ray tubes, first one is the CRT monitors. So this is also called cathode ray tubes. Okay, CRTs are big, as we see in the picture now. We use earlier time this type of monitors. These are big, bulky, their weight is very much and consume lot of power. Yes, they consume lot of power consumption. Their power consumption is much than others. This bulkiness is due to in large part to the CRT technology, because the technology is using in the CRT. That's why their bulkiness. That's why they are heavy in their weight. So the technology is using in the CRT. But which technology is using in the CRT? Vacuum tubes. They are using the vacuum tubes, large vacuum tubes. Okay, which requires a certain distance, because as we see in the picture now, this is a vacuum tube. They need a more space. They need a more space. That's why the CRT monitors are in heavy weight and are large in size. The CRT is made up of a large vacuum tube that uses electron beams to generate an image on the phosphorescent surface of the screen. The screen is made up of the phosphorus surface, okay, of the screen. So this is a, as you see in the picture, there is some electron gun. When the electron gun projected, some electron gun is projected in the fluorescent screen. That is also called phosphorescent surface, which is phosphorus is present in the screen. So when the electron is sending on the through the electron gun on the phosphor coated screen, you will see the image on the screen. You will able to see the image on the screen. The screen phosphor coating is organized into the grid of dots. There are so many dots. When you when the image, when the gun gun is shooted, electron gun is shooted with some electrons. The electrons, they will affected on the screen, and your screen will be like you can say that it will be produce some light. It will produce some light. There are so many. It can be black and white color or it can be colorful. If your electron gun is RGB, red, green, blue, then they will produce the colorful screen. If their screen is color black and white, they will produce only black and white color. Okay, so electron gun only focus on the pixels. When you electron gun shoot, the electrons will strike on the screen, phosphorus screen, and the pixel will be blinked. Okay, so this will be able to see the screen image on the screen. Next is, this is the basic difference. See, in CRT you use the vacuum tubes. That's why their weight is heavy. So and phosphorus screen. Phosphorus coating screen is surface is present on the screen. Okay, this is the basic difference. Now LCD. LCD stands for liquid crystal display. LCD is a flat panel display technology commonly used in TVs and computer monitors. We are today's using now we are using LEDs, but before LEDs we use the LCDs. LCD is a liquid crystal. Which technique is using in this LCDs? Liquid crystal. In CRT, vacuum tubes are using electron gun projected on the screen, phosphorus screen, and in LCDs liquid crystal is using in the LCDs. It is also used in screens for mobile devices. Yes, LCD is used on the mobile devices such as laptops, tablets, and smartphones. LCD displays don't just look different than bulky CRT monitors. As if we see, anybody can can make the difference between, because LCD are slim and CRT monitors are heavy, and they are in expandable form. The way they operate is significantly different as well. Obviously, it's in CRT we are using we use the vacuum tubes, and in LCDs we use liquid crystals. Instead of firing electrons at a glass screen, an LCD has a backlight. In LCD, there are some layers. As you see in the screen, in the image, you will see there is a backlight. Backlight at the last layer. Screen is at front side. Display where you are seeing able to see the image, that is front. Back side there is a mirror like screen. There is a backlight. Backlight means to say when you give the current, electric current to the LCD, switch on your LCD, then there is some backlight. It will be there is a backlight, you can say that in the tube lights. You see na tube lights in your homes. Now LED bulbs are using, but before some homes there are some tubes are LED tubes used. You see LCD tubes. LCD tubes used in the home for the light.
You mean the tube lights, ma'am?
Yes, tube light. I am telling about the tube lights. Yes, that tube lights same as like these tube lights are using in the LCDs in the for the backlight. When you switch on your LCD, the tube lights switch on. They gives a light on in your tube lights, and these light goes in the liquid crystal layer. There are many layers. So when you switch on your LCD, there is some backlight. Your tube lights switch on. They produce light, and this light enters into the liquid crystal layer. Okay, liquid crystal layer. It passed into the liquid crystal layer. Then it will pass to different layers, and then it will goes to in between there is a RGB means to say red, green, blue, which produces colors for the image, which helps to produce the image colors for the image. So this is the basic difference. There is a backlight, which backlight is in which form? Tube light form. Okay, there is a which this crystal is using liquid crystal. Liquid crystal is you can say it is not in the solid form, it is not in the liquid form, it is in between the solid and liquid. When you give some when you pass electric light on this liquid crystal layer, it becomes it produces some suppose it becomes bend. How can I will give you 1 second. I have to draw. Yes. Yes. So this is layer. Here is a, when you pass some like when you switch on your LCD, there is some lights, tube lights. There is some tube lights are present. Okay, so this will be on. Light will be produced from this tube lights. Okay, when the light will be produced, there are some layers. There is a liquid crystal layer. First there is a vertical layer. There is a vertical layer. Okay, so there is some vertical layer. Okay, so the light will be passed from this vertical layer. There is liquid crystal layer. Now this is liquid crystal layer. Okay, this liquid crystal layer will be bent. Like they can be mold. They can be mold when the light is passing from this liquid crystal layer. Your liquid crystal will be bent, and there is a horizontal layer. There is a horizontal layer. Now this liquid crystal, this is a liquid crystal layer. So this is looks same, but this is a liquid crystal. You can say this is in the round shape or elliptical shapes. So there is first one is a tube lights, second is a vertical line, third is the liquid crystals layer, fourth is a horizontal layer, then there will be the RGB, and then there is also one layer, then there is a screen. Okay, fluorescent, this is also a fluorescent screen. When the light backlight, there is a backlight is passing from these layers, liquid crystal will be molded, and this molded will pass through the horizontal because of this moldness, it will easily pass from the horizontal layer. It will be easily passed from the horizontal layer, then it will enters from the RGB. The colors will be produced. When color will be produced, it will strike on the screen, and you will able to see the image on the screen. So this is very fast. This mechanism happens very fastly. So you can't feel these things. But the main process is CRT. We are using vacuum tubes, and electron gun projects on the phosphorus screen. Okay, and in LCD there is also pixels on the screen. Pixels is present in CRT also and in LCD also, but there is a mechanism is there is a tube backlight is present in the LCD, and liquid crystal layer is present in the LCD. Okay, this is the main basic difference in LCD. Okay, so we back to the text. Backlight that provides light to an individual pixel arranged in a rectangular grid. Each pixel has a red, green, and blue RGB subpixel that can be turned on or off. When all of the subpixels are turned off, it appears black. Obviously, when the pixels are off, you will see the screen black. When all the subpixels are turned on, 100%, it appears white. White means to say it appears colorful. By adjusting the individual levels of red, green, blue light, millions of colors. I told you yesterday class, from red, green, blue, there are so many colors. Millions of colors can be produced, are possible. Combinations are possible. Okay. Next is the LED. There is also LCD and LED. There is some basic difference in LCD and LED. Okay. Yes, this is a picture related to LCD. You can see in the image. I think.
Ma'am, LED is the latest version than LCD, is it, ma'am?
Yes, it is a latest version. But in LED, we are using tube lights now. Tube lights in the backlight. In LED, we are using the light emitting diodes. Diodes. You see now, small bulbs, like very small, tiny bulbs, diodes like.
Yeah, got it, ma'am. LED is light, small
Very
LCD.
small lights, yes, because you will see that LCD is much more wider than the LED. LEDs are slim than the LCD, but LCD are wider than the LED as compared to LED. LED are slim than the LCD, as you know, as you see in your homes. These diodes are tiny little bulbs. This picture is, I think I mentioned this is wrong picture. This is the picture related to the LCD. As you see in the last, you will see backlight. This is a backlight, and then passes through the, it's a polarized filter that is in vertical shape, then liquid crystal, and then is a horizontal colors, then horizontal, then you will see the glass. Okay, there are two filters. One is horizontally, and one is last one is vertically, and close to the screen is the horizontally. Okay, so these are the layers in between the LCD. Okay, this picture is related to LCD. I will change. So LED stands for light emitting diodes. These diodes are tiny little bulbs that you might have seen on electronic devices. Yes, large LED displays use a large number of these diodes to light up the screen. Yes, there are so many numbers of diodes are using to light up the screen. These diodes are low power consumption because LEDs take more power consumption as compared to the LEDs. Those provide high brightness, and brightness quality of obviously LEDs much more than the LCDs. As a result, an LED screen has several benefits over other display alternatives. There are fluorescent bulbs used earlier could only give black and white tones. However, an LCD can display the entire color spectrum by combining, yes, RGB. Everywhere you will see the color screen, RGB is using, because through RGB we can produce millions of colors. Okay, the basic difference in LCD and LEDs, there is a tube lights. Backlight is using in the form of tube light, and liquid crystals are the layer of the liquid crystal is using. And in LEDs, we are using in the backlight, we are using electronic diodes. Diodes are using, light emitting diodes are using in the LEDs. This is a basic difference between LCD and LED. So LED, OLED. Now OLED stands for organic light emitting diode. So as we study about the LCD and LED, the light is coming from the back side. The light is coming from the back side, and it goes, it passes through the layers, then it comes to the screen. So, but in organic LED, it is much slimmer than the these LED and LCD. These are these are this OLEDs generate its own. When you power on your power on the OLED, it generates its own light. They don't need their backlight. They don't need backlight. They generate their own light. Okay, to generate light or produce an image, an OLED display must pass an electric current through organic electroluminescent. There is a organic electroluminescent material is used, because the electrical current is passed through this material, and displays that can generate light without the need for the backlight. There is a no need of backlight. That is called self-emissive. These are self-emissive. They don't need to produce, they don't need of the backlight. They produce its own light. Self-emissive means the organic material used in construction generate light without any need for additional backlighting. Got it? This is a basic difference between these LCD, LED and OLED. Got it? Please give me.
Yes, ma'am. So OLED is something new I am hearing.
Yes, it is new. They are self-emissive. Okay. There are anode or cathode are layers are using. Organic layers are using you can organic electroluminescent material is using. In LCD, liquid crystal is using. In LED, backlight is using in the form of light emitting diodes. In OLED, organic electroluminescent material is using. Okay, they produce its own light. They construct their own light. Self-emissive. Okay, they don't need additional backlight. That is a basic difference.
As the name suggests, is it anything less harmful to
Organic,
eyes?
organic. It's a
Organic.
organic.
Okay.
organic electroluminescent material. Okay.
Okay. Okay. Ma'am.
Yes. Now plasma display. Plasma display is a type of flat panel display that uses plasma and electrically. This is there is also basic difference in this. The difference is there is using in the layers ionized gas. When the question comes na ionized gas, in which display ionized gas is using, only plasma display. Okay, which gases are using in the plasma display? Neon, xenon, and helium. Helium is also there. I'm not able to. I will correct it. Okay, 1 second. Yes, helium. Helium gas is also used in plasma display to eliminate each pixel in order to produce a display output. It is commonly used in one basic difference is that the size of the plasma display is not less than the 30 inches. Okay, it can be more than 30 inches but not less than 30 inches. It can be higher than 30 inches but not less than 30 inches. Okay, plasma displays are often brighter than LCDs. They are brighter than LCD displays. The plasma displays are also known as gas plasma displays. Got it? The basic difference in plasma displays, ionized gas. They are using ionized gas, neon, xenon, helium. Okay, to display to produce a display output. And the size, the TV disc size is not less than 30 inches. Okay. So some different ports, as you see now in previous PCs, some ports are using. Now today's the ports are different, as we know, according to our smartphones. Before now we are using Android. Some the cables are changing now. I think today we are using the C type cables. In Android phone, in Apple phones, the cables are different. That is called thunderbolt cables. So the different ports and different, obviously the if the cables are different, their ports is also different. So there are different ports and connectors which we use for displaying different graphics. Okay, like images, videos. Some of them are discussed below. DVI. So with these ports, with if the ports, why the ports are changing? Why the ports are changing? Because we use just for charging the smartphone, or just if we connect it to the laptop, we just share the files. But why the quality, if the why the ports are and cables are changing? Because the quality, when you improving the quality of the smartphones, the quality of the cables also improving. Why they are improving? Because the quality, because of quality of the images and videos. You can see the quality of the images and videos. That's why the display ports and connectors is also improving, changing. DVI. First is DVI. DVI is a digital visual interface. So please remember the full forms of these uh, every DVI, HDMI, as these. Okay, so note down these full forms. These connectors carry only the video signals in three ways. DVI only used for the video signals. There are three ways to carry the video signals. One is the digitally, as we discuss about the digital and analog. So DVI D is the for digital. Other DVI A is for the analog signals, and third is the DVI II. It integrates both digital and analog. Okay. This is a basic difference between three types of DVI using DVI D, DVI A, DVI I. DVI D is digital, DVI A is for analog signals, DVI I is integrates digital and analog. Okay. used for only video signals. HDMI is the higher definition multimedia interface. HDMI can carry both video and audio signals. This is mostly used for theater displays. As we know, in the theaters displays as well as in monitors, HDMI interface is using. This type of connectors are using in the HDMI. Okay. So HDMI special kind of ports are used. So this is basically every connector has every specific port, special kind of port. S video. These are connectors. DVI is also connector, HDMI also connector, S video is also connector, and display port. S video. S video is it stands for separate video. It stands for separate video. It also carry both video and audio signal, but its resolution is low as compared to the HDMI. Its resolution is low. It has 4 pins only. Component RGB video. And RGB understand red, green, blue. This uses 3 connectors of 3 colors, red, green, and blue. These are mostly used in televisions and other displays. Now today we are not using, but earlier time we use this type of connectors. These are not suitable for PC display. These carry only for video signals, as we see in the picture. Okay, this is the HDMI, DVI. This is the S video. This is the component. Are you able to see in the picture?
Yes, ma'am. Yes, ma'am.
Yes, one second.
But some of these are also now
We are not.
outdated now.
Yes, they are obsoleted. Some are obsoleted, but in old PCs, these things, these cables are used. Yes. No color is.
And the ECG that they take in hospital, that is analog.
Yes,
thing,
yes,
ma'am.
yes, yes. That is a yes. Yes. Now this is the component. This is the composite, and this is the S video. This is DVI. This is HDMI. Display port. These are all are connectors, and these are all are ports. For HDMI cable, we use this type of port. For DVI, we use this type of port. For USB-C cable, we use this type of port. This is for the Android phones. Oh, sorry, Apple phones. Okay. VGA. Earlier PCs, in old PCs, we use this VGA. And component video for composite video. Okay. So composite video. It is simply yellow color connector. As we see in the picture, composite it is yellow, but why they are connected with red and white? It's yellow color port in the RCA cables. RCA means to say radio cables of related to America. It is used only for video signals. So yellow color connector is only used for video signals. When you want audio also, you have to add red and white. You have to add cables of red and white for audio also. Okay. These are others RCA connectors which are used with the composite video connector in order to carry audio signals. That's why we use red and white. Composite. That is why composite. Mostly used in the televisions and satellite receivers. VGA. VGA is a video graphic array. These are mostly used in the PCs and projector displays. It carries analog signals for displaying. It has 15 pins, 5 pins in each 3 rows. There are 3 rows and 5 pins in each row. It has its own special type of port on the system. Obviously, if the connector is different, the port is also for that. This is a VGA, okay, and this is a VGA port, okay. This is a cable and this is a port. So Thunderbolt. Thunderbolt sign is here. You will see in the cable. This is a Thunderbolt sign, like electricity, like this. So this is mostly used in the Macintosh PCs. Many small devices. These can carry both video and audio signals as well as data from one device to another. These connectors have their own ports with a special symbol on them. Special symbol of Thunderbolt. Okay. Display ports. These port works same as Thunderbolt. Its shape is almost named as USB port. This is a display port. Okay. This one is a display port. Okay. But with slight changes on one corner. Yes, as we will see in the picture, this is a display port. You see the difference in the this is slightly uh, corner shape is different than the other ones. It's slightly different. Okay, so that's why there is a basic difference between the Thunderbolt and display port. The work is same. Okay.
I think projectors have that display port, ma'am.
Now
I'm
today's
not
time, earlier
familiar.
projectors, the old projector use the VGA. Okay. Now today's we use the display ports. Okay. USB ports, as we normally use the USB ports. As discussed in the previous blog, it is one of the mostly used technology for transferring data and visual display signals in today's era. It has different, because basically we use USB cables. It has different types and different generations, because there are so many examples related to types related to USB-C cable, USB-A cable, like this. So we have finished. The time is over. Okay. So please ask question if any doubt.
So
Then
are we done with the ICT portion, ma'am?
ICT. Sorry, one second. We didn't complete the ICT. We completed just display unit. We will tomorrow we will finish printers. Can I take the class 1.5 an hour, 3 days, up to 3 days? Only for 3 days, because I just want that printers and motherboards we completed tomorrow. Like one portion will be completed. We will complete it one portion. Sorry.